I know that not everybody did the Chapter 27 homework, and that's totally fine. But let's go ahead and cover those questions. The two types of three-phase connections are the Y and the delta. Number 3, we have a Y-connected load with a voltage of 480 volts applied to it. What is the voltage across each phase? So loads are connected to the line terminals, and so that means this 480 volts, that is line voltage. And if you look on page 626 in the middle, you'll see the formula for this. So we have, sorry for my bad writing here, we have phase voltage equals line voltage divided by 1.732, and that gives us this the 277 volts. Number 4, a Y-connected load has a phase current of 25 amps. How much current is flowing through the line supplying the load? And if we look again on page, in this case, 627, figure 27-7, phase current equals line current. So our phase current is 25 amps. That means our line current is also 25 amps. Excuse me. Number 5, a delta connection. So now we're switching to a delta connection. Has a voltage of 560 volts connected to it. How much voltage is dropped across each phase? Page 629, figure 27-15 shows this. So with delta connections, E phase equals E line. So E phase equals line, E line, or line phase voltage equals line voltage. Number 6, a delta connection has 30 amps of current flowing through each phase winding. How much current is flowing through each of the lines supplying the power to the load? So we're given phase current and we need to figure out line current, and this is a delta connection. In the textbook, it's page 630, it's around the middle of the page, and it shows that line current, again, sorry for my poor handwriting here, equals phase current. Oh, this is looking really bad, but hopefully you can see what I'm writing, times 1.732. And that's how we get the about 52 amps. Ooh, that was a bad underline there. Number 7, and finally the last one, a three-phase load has a phase voltage of 240 volts and a phase current of 18 amps. What is the apparent power of this load? So if you look at page 631, section 27-4, that shows this in more detail, but we're given phase voltage. And when we're given phase voltage, the formula for the apparent power is VA equals 3 times phase voltage. I'm just going to put a P here, times phase current. And that gives us the 12.6 kilovolt amps. Again, a bad underline there. My apologies for that.